This tiny fruit fly is about to enter the world of virtual reality.
What we have going on right here is we have a fruit fly that is actually walking on this spherical treadmill, a little ball that's supported by air. We essentially put it in virtual reality with its stimuli, but the stimuli, the sounds, the odors, and the visual cues are patterned exactly as they would be when the male is interacting with the female.
With support from the National Science Foundation, neuroscientist Mala Murthy and a team at Princeton University want to understand how animals process information and communicate with each other during social interactions. She focuses on courtship and mating behavior, using the fruit fly as a model system.
How are the hundreds of thousands of neurons in the fly brain, or the hundreds of billions of neurons in the human brain, how are they capable of sensory perception, thought, and ultimately communicating with another individual?
Understanding how flies think starts with breaking down how they move. Physicist Bill Bielek mathematically models animal movement.
We're trying to actually characterize the complexity of the behavior and build a mathematical description that matches the real complexity, not something that we impose on it.
Biophysicist Joshua Shavitz goes a step further, taking movies of flies in motion, then using computer algorithms to sort and categorize all the different things they do. He's been at it for more than 5 years and analyzed about 1 billion images.
We now have a decent handle on how to ask the question, what do flies do? Either when they're by themselves or when they're with others and things like that. And so now we are taking on the harder question, which is how do they interact with each other?
Murthy wants to watch individual neurons firing in both male and female brains as courtship plays out. They're rigging the virtual reality system to do just that, as the male sings a song he generates by vibrating his wings.
So he's constantly paying attention to how fast the female is moving and how far away she is from him. And he uses those two pieces of information in real time to change up what he sings in order to seduce her. She wants to choose the fittest male to mate with, and she takes upwards of tens of minutes before she makes a decision. And so during that time, she's integrating all of this information and changing her behavior in response to him.
Murthy says what they are learning ultimately will lead to a better understanding of interaction and communication in many animals, including humans.
I think the insight we gain can serve as a starting point for neuroscientists that work in more complicated brains, mammalian brains or on the human brain, thinking about how pattern recognition or producing speech patterns goes awry in cases like autism or other disorders that affect social interactions.
Great reasons to keep on the ball with a little guy like this.